Hello. Well, today we're going to be like Langston Hughes and discuss roots. However, it's not like your family roots or roots of plants or anything like that. This is roots in mathematics because this is a mathematics course. Well, roots. We talked about powers and exponents recently. Roots are just inverse operation or the inverse of doing a power or an exponent. In fact, it's kind of weird to actually say that because a root itself is really just a power or an exponent. It's just a different kind. We'll talk more about that in a future video. But for now, let's talk about roots. Mainly, there's going to be two that we talk about. We're going to talk about square roots, and we're going to talk about cube roots. Um, in actuality, I put this little radical symbol, and many of you have seen that before, and I put a two kind of like in the holder in the front. And for the other one, I did the same thing, a radical, and I put a three in the little holder in front. Actually, I don't have to write the two one because if you just see a radical and no number in front, it is automatically known to be a square root. Because that would be the most basic of roots that we'll use. I guess technically there could be a first root, but the number would just be itself. Um, so that is the reason why we don't have to put a number there for the square root because the truly basic one would just be unnecessary. So we have a square root and we have a cube root. Those will be the ones that we will use in this class and then in the next class. Those are the ones that are most commonly used whenever you are doing work in your designated fields of applied science and technology, and just normally in the world. Now, so as I said before, roots are going to be the inverse of those exponents and powers. So, of course, you can go past third root, but again, for this course, and majority of the time, you won't be using them, so we will not discuss them at this point. But let's talk about what a root is and how to use it. So actually, we've already talked about what a root is. Well, how do we use it? How do we use this root? Well, if you have 2 to the second power, that's really just 2 times 2. And many of you will say, oh, that's 4. And guess what? You would be correct. Um, but let's say we wanted to undo that. We wanted to undo the square. Well, if we have 4, we could take the square root of it and get 2. And that would undo the exponent. This becomes very handy whenever you're trying to solve an equation that has something squared. And for instance, many of you probably have seen problems like area of a square or area of a circle, in which you take a distance or a length or a measurement and you square it. Well, if you want to get back to what it was originally, you would have to take the square root to find it. So in this case, square root of 4 would equal 2 because 2 times 2 equals 4. Because when we take the same number times itself, we get 4. So square root of 9 would be what? And many of you probably are like, oh, I know this. I have this on the routes. Let's say you didn't. What this is actually asking is, what number can we multiply times itself and get 9? Well, that would obviously be 3. Because 3 times 3 equals 9. So let's say you had a larger number that you were unaware of exactly what the square root would be. Is there a way for you to estimate it? Well, yes, there is. So let's take good old square root of 144. This is a common one that people have trouble remembering. Not really. A lot of people remember this one for some reason as opposed to ones that are smaller than that. But the square root of 144, let's say you didn't know what it was. Well, do you know numbers that multiply to give you 144? Many of you may say 12 times 12 off the top of your head, and then, oh, well, that's already the answer. But let's say you didn't. Well, we know that this number is even, so it must be divisible by 2. That means that 2 times some number gives you 144. And the number happens to be 72. Okay. Well, we know that 72 is also even because it ends in an even number. So we can do the same thing there. And so we get the square root of 2 times 2 times 36. It's the same thing as the square root of 144. Well, notice how I have 2 of the same number here? If you have two of the same number multiplying, that means it's that number squared, correct? And we're doing square roots, which will undo squaring something. So this would really give us a 2 times the square root of 36, because we still don't know what that is. Or maybe we do. Square root of 36. Square root of 36 would be, of course, 6, because 6 times 6 equals 36. And at this point, then we have a 2 times a 6, and we know that that is 12, which, meaning you said at the beginning, that's exactly what we would get, right? The square root of 140 would be 12. 144 would be 12. That is correct. But as you can see, there's another way to find this. You can factor or break apart 144 to see what numbers multiply to get to it. And you can keep doing that until you get two of the same. If you have two of the same number, then you can bring it outside the square root. Why? Because square roots undo squaring something. And if you have two of the same numbers multiplying, that is squaring it. All right. But what about a cube root? Can we do the same thing with a cube root? We can't. The square root told us if we have two of the same number multiplying, then we can undo the square. For a cube root, though, how many numbers would we need multiplying? We need 3 because it's a cube, right? So let's say we're taking the cube root of 27. Well, we need 3 numbers that multiply together, this same number, multiply 3 times to give us 27. Some of you may know it off the top of your head, some of you may not. So let's see if we can, we're doing a cube root. So let's see if we can factor or break apart 27. Well, we know 27 is the same thing as 9 times 3 from our multiplication facts. And we know that 9, we can break that up, right, into 3 times 3. We have 3 of the same number. That means we can undo this cube. So therefore, the cube root of 27 is the same as the cube root of 3 times 3 times 3. So therefore, it's 3. All right. So we can do the exact same thing with a cube root. Let's do one more. And this is one that I see people commonly make a mistake with. We're going to do the cube root of 64. Now, some of you may say, oh, that's 8. That's not right. The square root of 64 is 8. The cube root of 64 is not 8. Remember, cube root, we need 3 of the same number multiplying in order to bring out. With square root, we need 2 of the same number. But we can use the fact that we know 8 times 8 gives us 64 to help find this. Okay? Well, can we break these up any other way? Well, many of you may say that 8 is the same thing as 2 times 4. And so this is really the cube root of 2 times 4 and 2 times 4 again. Well, there's a couple of different things we can do here. We can either break 4 apart, or we see that 2 times 2 equals 4. And so this really just gives us 4 times 4 times 4. Because remember, the end goal is to get 3 of the same number. If we didn't do that, we would have had 2 times 2 times 2 times 2 times 2 times 2. And then we would have had 3 of the same number here and 3 of the same number here. But either way, our final answer would have been 4. So you can break it down as much as you need to, or until you get 3 of the same number. It doesn't matter. But in the end, for a cube root, you need 3 of the same number. For a square root, you need 2 of the same number. What if there was a 4th root or a 5th root that was asked of you? It won't be, but I believe at this point, you begin to understand that if it was a 4th root, you would need 4 of the same number multiplying. If it was a 5th root, you would need 5 of the same number multiplying. If it was a 112th root, you would need 112 of the same number multiplying. I hope that you never have to come across that. But if you do, you could do it. Because with a root, you're just undoing what an exponent would do. And so exponents multiply the same number a certain number of times. With roots, we are looking for what number do we multiply the same number of times to get what we're starting with. And so that is our roots. And I said again that roots, powers, and exponents, actually a root is just a exponent. It is a power. It's just a different kind. And we will talk about that in a later time. Um, but for now, it's important to remember what numbers are going to be perfect square numbers or perfect cube numbers, because it'll make it a lot quicker to solve these questions, or also to give us a good estimate of where our answer would be. Um, for example, if I was going to do square root of 5, I can't actually take the square root of 5, but I know square root of 4 is 2 and square root of 9 is 3. So square root of 5 must be between some number between 2 and 3. So yeah, that is roots. And I will see you again soon.